Hi guys, Meteorologist Alexandra Cranford here on this Monday afternoon at 1 p.m. Thank you for joining me for today's weather lesson. Today we are talking about lightning. I'm really excited about this one. We've been talking about all these different topics last week and then into this week. We're beginning on Monday with lightning, and we will be something that we're doing in the next couple of days. I just saw that my connection was low for a second, so can you guys hear me? If you can, give me the thumbs up and let me know if you can hear me. I hope my sound didn't drop out. That happened once over the weekend. What we're talking about today is lightning. So welcome to all of my friends who are joining me for yet another weather lesson. We're talking live today, and welcome especially to students. If you can, kind of like you did last week, send me a little message if you can comment in the comment section and let me know where you're watching from. I would love to see where you guys are tuning in to this weather lesson from, whether it's from New Orleans or from the North Shore or from a different part of the area or a different part. So let me know. And again, please let me know if you can hear me. If you can hear me and the sound is good, let me know and I'll be able to continue without stopping and starting over again or something. Yes, I'm seeing some likes, yes? Okay, everything might be a little bit delayed, but we're talking today about lightning. So, lightning, obviously really, really gorgeous and beautiful. And Dunlop and this weather book for all of these cool pictures, gorgeous, gorgeous bolts of lightning. And what we're going to talk about today is, first of all, how lightning forms. Then we're going to talk a little bit about lightning types. We're going to talk about some different lightning facts, because there are some really cool things to think about with lightning. And then we're going to be getting into a couple of cool things. For example, many of you may know about the rule that lets you determine how close a storm is to you based on the lightning. Okay, cool. I'm seeing some comments pop up. Hopefully the sound is okay and we can continue. We're also going to talk after that about lightning safety. And we are eventually going to get into very quickly some things on general thunderstorms. And eventually I think we're going to do a little lesson maybe on severe thunderstorms. But today it's mostly about lightning. So thank you guys for joining me. Let me know if you can hear me. I really hope so. I'm seeing some comments pop up. I'm seeing people tuning in. So on my end, it looks good. I hope that it is on your end too. And again, give me the thumbs up if you can hear me. Okay, so we will get into it then. Lightning. So cool to see, very beautiful, also extremely dangerous and very powerful, something very interesting to talk about in the weather world. Great, we hear you, Alexandra, great. So what happens to get lightning to form? First, what happens is, remember last week we talked in our lesson, I think it was 2, about clouds. And we talked about a certain kind of cloud called cumulonimbus, which is those really, really tall clouds that form vertically in the atmosphere and go way up high. So with cumulonimbus clouds, and again, this would be an example for reference purposes of a cumulonimbus cloud, one of these really tall storm clouds. You have all kinds of stuff going on in these thunderstorms, which is one reason weather is so interesting and storms are interesting as well. But one of the things that you have is a collision of particles. You have raindrops in there, and you also have ice particles and ice crystals. And when these collide, what it does, and hopefully many students will know a little bit about this, and if you haven't gotten to this point in your science classes yet, don't worry, not a big deal. We're just going to talk about it quickly. But what it does is it knocks off of these atoms something called electrons. So if you've gotten to this point in your science courses where you know about this, matter is composed of these tiny, tiny little bits called atoms, and they have positive charges and negative charges. So when the ice particles and raindrops collide in these tall thunderstorms, these cumulonimbus clouds, what happens is the electrons, the negatively charged particles, get knocked off. And eventually what happens is, when these collisions keep happening over and over, the negative charge, electrical charge, starts to build up. There are all these little negative particles, and they begin to form and kind of gather at the base of the cloud. Something else interesting happens, which is that the positive charges go to the top of the cloud, and positive charge along the ground begins to kind of react to what's going on in the cloud. So what we're talking about right now first is what we would call cloud to ground lightning. And that's the kind of lightning that we'll talk about just to kind of get into how lightning forms bit. So what we essentially have when we are talking about the charges is positive at the top of the cloud, negative forming along the base, and then positive charge collecting along the ground, and especially along tall objects like lone trees or the tops of maybe tall buildings. And so that's where we start to see a lot of positive charge collecting. There is a big imbalance between really strong, eventually strong negative charge at the bottom of the cloud and strong positive charge on the ground. And when there's this big imbalance, nature wants to correct it. It wants to get everything back to normal. So this would be the point at which we start to see the imbalance so strong that negative charge from the base of the cloud starts forking downward. And so that's in something called a stepped leader. At the same time, and kind of just as or just after that's happening, the positive charge along the ground begins to respond, and it is drawn up from below. As the negative's coming down, the positive almost instantaneously reacts and moves upward toward the cloud. And that, as the positive charge, when these two meet, the electrical current flows between them and a huge wave of the positive charge surges upward, and that creates the brilliant flash that we see. So that's the lightning right there. Interestingly, a sort of less visible step leader has to happen first before you see the big, beautiful, and in many cases very striking lightning flash happen. By the way, it doesn't always have to be negative at the base of the cloud and positive along the ground. Sometimes it's opposite. Sometimes there are positive charges, not often, but a little more rare would be a positive charge collecting in the cloud and negative along the ground. But in most cases, it would be negative in the cloud base and positive along the ground. So lightning happens not just, as we just said, from cloud to ground, but also it happens from cloud to cloud. You may have seen that with thunderstorms happening. You may have seen that, we have many thunderstorms in Louisiana, of course, in the summertime, so that may have been something that you've seen before. The most common is actually within a cloud, within the same cloud. And there's also lightning that can happen from a cloud, not to the ground or to another cloud, but just into clear air. So that is also something that can happen. So those are different types of lightning that we talk about. So now that we know how it forms, we know a little bit about the different types that we can have, there are some really cool facts that have to do with lightning. So for example, lightning is extremely hot. When we talk about hot, you could say, with a fever, your body is getting to maybe about 100 degrees Fahrenheit, a little bit above that perhaps. When we talk about how hot the air gets when lightning passes through it, we're talking about up to 50,000 degrees Fahrenheit. So about 5 times hotter than the sun's surface. That's how hot the air can get as the lightning passes through it. So that is something to think about, of course, how hot it gets, and it's also what produces eventually the thunder that we hear, that reaches our ears. The air heats up so much, so fast, it just expands really fast and begins to vibrate, and our ears pick that up in the form of a thunder bolt that we would hear. So lightning, very hot, produces thunder as well. And when you think about the difference between lightning and thunder, of course, they're happening simultaneously, but there is this cool rule that you may know about, some of you, about how to calculate how close a thunderstorm is by looking at the difference between the lightning flash and counting until you hear the thunder. So this is how it works. It's kind of the counting rule. You see the flash of lightning and then you can count. You can either do it on your phone with a stopwatch, something like that, or you could just count 1 Mississippi, 2 Mississippi, 3 Mississippi, and you count until you hear the thunder. And then whatever that is, it is corresponding to fives. So if you count 5 seconds between lightning and thunder, you can divide that by 5, and you can find out how many miles away, roughly, the storm is. So in that case, for 5 seconds between the two, lightning and thunder, that would equal the storm being about a mile away, 1 mile. So can you think about, for all my student friends, little math problem. I don't know if you've been doing a lot of that lately, maybe not over the weekends, huh? But getting into that, if we were to count 10 seconds, for example, we'll do a little example. If we have the lightning flash and then we go 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi, and then you hear the thunder, that would equal 2 miles away for the thunderstorm. And if you only counted maybe 2 seconds, if it went really fast and you see the lightning, and then you count 1 Mississippi, 2 Mississippi, and then the thunder's right there following only 2 seconds later, that would mean the storm is pretty close, less than a half mile away from where you are. So cool little rule if you can remember that. And if you can't remember it, don't worry, you can always just look it up. Okay, there is something that we talk about in Louisiana sometimes called heat lightning, which is a little bit of a myth. Did you know that heat lightning, many of you may know this, but it's kind of that lighting up of the sky that we see at night. That's really just a thunderstorm happening a really far way away and illuminating the sky for a second. It's not a particular type of lightning, it's just something that happens when there's a very distant thunderstorm forming lightning, and that we are just kind of picking up on the light. So something, a little tidbit in case some of you don't know that, maybe some of my students' friends don't know that. So now we're going to talk a little bit about lightning safety. So lightning, by the way, if you're wondering about how many people it kills per year, it's about 30 per year. I've seen different numbers ranging from about 20 to 50 or so. Hundreds more, though, in the United States are injured by lightning. Lightning can also be very dangerous because it can strike houses and buildings and start fires there. And it can also spark forest fires. So there are all sorts of things that lightning can cause, although it's cool to see, and a lot of us maybe like to see these beautiful pictures of it. Of course, it's very powerful, very dangerous, and a lot of safety measures need to be taken because of lightning. So we'll go over that really quickly. What you should do with lightning. First of all, the first thing for sure, find a shelter. If you can get indoors, that is the best. Even if you're a little ways from a sheltered area, if you can find one pretty close to you, if you see a thunderstorm coming and you're stuck outside, it is always best to try to get to an actual building and get inside a shelter. If you are in a car, that is not bad. You could stay in your car too. It has the metal framework that would protect you as well. You never want to go near a lone tree or something spiking up, because lightning often will move to that point, to a lone tree or something like that. If you're out in the open and you absolutely cannot get to a shelter, there's just absolutely no shelter anywhere near you, the thing to do in that circumstance would be maybe to find a kind of group of trees, not just one, but get in there, possibly if you could find a group, and crouch down and try to stay just on the balls of your feet. Don't lie down, because that increases the surface area of your body along the ground. So if you can just stay on just kind of the tips of your feet and crouch down, that would be the best thing to do if there's absolutely no shelter or even a car available that you could go in. Don't resume activities after a lightning storm until roughly 30 minutes. We know about lightning delays with sports games. I used to play soccer. Maybe some of you kids play soccer or baseball or something outdoors like that, and you may have had your games delayed before because of the lightning, of course. So if it's in the area, even if it's not a thunderstorm right overhead, lightning can happen a good ways out, away from the actual thunderstorm. So that's why we take it seriously, and why you may have had some of your games postponed or delayed or things like that. So you want to wait about 30 minutes until after you hear the last thunder. That's kind of just the general rule. Lightning, by the way, and house fires, just to give you a few tidbits about that, it sparks about 22,000 house fires in the U.S. Each year. Isn't that something? Thousands and thousands of houses and buildings do get struck by lightning, and fires can result from that. Most often, can you think, especially my student friends, when in the year we might have most of the lightning strikes and lightning hitting houses? Can you think of that? Would it be, especially for South Louisiana, in the winter or in the summer, do you think? If you think in the summer, then that would be correct. The most common months for these kind of disasters with house fires caused by lightning, and the most lightning happens typically in the summer, June, July, and August. And during a day, when do you think that it might be the most lightning strikes happen during the day? Do you think that would be maybe at night or maybe in the afternoon or morning? If you say morning, not really. The answer would be afternoon, with a peak around 5 p.m. And that makes sense, especially we know in New Orleans, in South Louisiana, we get, especially during the summer, afternoon thunderstorms that form when the daytime heating has brought our temperature way up. There's a ton of moisture in the atmosphere. It's hot, it's humid, and these afternoon thunderstorms typically form right there in the late afternoon, early evening. And so a peak of lightning strikes happening right around 5 p.m. It makes sense, right? Because we have seen that. And then once you lose daytime heating later in the evening, and moving into the nighttime hours, typically a lot of those afternoon thunderstorms begin to calm down and die down. By the way, lightning often ignites the attic of a house first and then spreads to the rest of the house. The best way to protect your house is with a lightning rod that looks like a metal stick, or any kind of building. Big buildings especially, of course, have these built in, and it safely directs the energy into the ground. And the top state in the US, another little lightning fact for lightning, is it's most common in the state of Florida, but Louisiana is not far behind. What you need to have a thunderstorm really is to have the lightning in there. That is part of what kind of defines a thunderstorm as opposed to a shower or just a regular kind of area of rain. So you need the lightning to get a thunderstorm. But even though lightning can be deadly and it can be very dangerous, lightning is not a criteria for a severe thunderstorm definition. The criteria that we look at for severe thunderstorms, I'll touch on really quickly, either hail that's an inch or bigger in diameter, so big hail, not small pea-sized or even dime-sized hail, but 1 inch diameter hail. That can be a criteria for a severe thunderstorm. Also, wind gusts of 58 miles per hour or higher. And also the presence of a tornado, or tornadoes kind of suspected or seen with rotation that we detect on radar. So those are the 3 things that qualify a thunderstorm as being severe as definitions go. Of course, if you were in the middle of a lightning storm and there is tons of heavy rain and there's a lot of lightning, then of course to you and to me, in my mind, I would say, woo, this is a really strong severe thunderstorm. But for the actual term severe, it needs those 3 things, either the large hail, the high wind gusts near 60 miles per hour, or the presence of a tornado. And very quickly, before I let you guys go, you may know about the difference between a watch and a warning. And it's funny how often we do hear that, those 2 words just kind of get mixed up in our minds a lot of times. A watch would mean that there are a lot of ingredients present for a severe storm or a tornado or whatever we're talking about to take place. So conditions are favorable for something like that to happen. But the more serious of the 2 would be a warning. A warning means that it's happening, or we think it might happen really soon, within the next few minutes or so. So just a quick reminder about the difference between those 2. Watch is a little bit more general, and it kind of corresponds with what you would think, just kind of watch. We're watching for something to happen because the conditions are there for it to happen. And a warning would be more focused on take cover, take shelter. There is a severe thunderstorm, or there is a tornado, or we're seeing signs that there probably is a really high wind gust or tornado or something like that, or whatever the element of the storm is that we're thinking about. So you guys, that'll do it for right now. We've been talking about lightning today with all these beautiful images that we often see with lightning. And of course, you guys are usually very good about taking beautiful photos and often sending them to us at WWL-TV or texting it to us at WWL-TV. So thank you for that. When you do safely get a photo like that, we do love to see it. Very beautiful, but also very dangerous. So thank you guys for being with me as we talked about lightning, how it forms with the positive and negative charges. We talked about different types of lightning. We talked about some lightning safety tips, some cool lightning facts, like that it heats the air to 5 times the temperature of the sun's surface. And then we talked a little bit about strong and severe storms, watches, and warnings. So to all my students, thank you so much for joining me today. I hope that taught you just a little bit about lightning and maybe reminded you about it if you've already covered some of this in school. And for adults joining me, I know it's such a weird time right now to be doing something like this at 1 p.m. From my house as I am still under self-quarantine, but this is what we're doing. This is what we're doing this week. So thank you guys for all your comments too, by the way. I'm seeing them pop up. Again, let me know when you can, wherever you guys are joining me from. I like to see where you guys are. And we will do this the rest of the week at 1 p.m. So if you can join me, maybe think about having some lunch and then settling in for a quick little Facebook Live weather lesson, and get your kids to join too, as they may be off from school and may just want to get into a little bit of learning while they can. So that'll do it for today. We're going to be back with more tomorrow. So join me Tuesday at 1 p.m. here on Facebook Live and WWL TV's Facebook page. Some of you, by the way, have been asking if there's a place where you can find more of these, and we are working on that, on getting them in an order somewhere. But for now, if you want to go back and see some of the older ones from last week, this is the 4th so far. You can just go to my Facebook page. It's just Alexandra Cranford. And if you click on it, scroll down a little bit, and I've shared all of these on my page. So you can find it that way. It is also on WWL TV's page, but you'd have to scroll down a lot. So I think that might be the easiest way to find it at this point. So thank you guys again. I hope you guys have a great afternoon, and thanks for joining me about this weather lesson on lightning. Hope to see you tomorrow at 1 p.m. and probably most days this week. We'll continue doing this after lunch. So thank you guys. Have a good afternoon.